Simplifying rational expressions. So we've already talked a bit about the root word of rational is ratio. So we're talking about fractions here. So another way to think about this is we are simplifying fractions. And the critical phrase you need to remember that I will just abbreviate FFCC is this. We are going to factor first, and then you can go cancel crazy. Now, I know that that's kind of corny and ridiculous, but if you make the mistake by not factoring before you cancel, then I'm just going to write on your homework or test or quiz FFCC. You can only cancel after you factor. That's it. FFCC. Let's do a few problems. So, once again, wrote it at the top of the page. There is no canceling anything until you factor. And that even goes for fractions as simple as 36 over 45. If we wanted to cancel anything, really truly the first thing we need to do is think about factoring. If we factor 36, we could do a factor tree for 36, and if we did a factor tree for 36, 6 times 6, 2 times 3, 2 times 3, so it would be 2 times 2 times 3 times 3. Of course, I'm showing you an extreme example here because I want to get the point home. 45. 45 is 9 times 5, so that would be 3 times 3 times 5. Now, what's really happening here when we reduce this fraction is we are canceling 3 over 3. And why are we able to cancel 3 over 3? Because it's equal to 1. And 1 is the multiplicative, big word of the day, multiplicative identity. Remember, if we multiply by 1, that allows us to rename a fraction. We've already talked about that. It also allows us to not change the value if we multiply by 1. So 3 over 3 is 1. 3 over 3 is 1. So that's what's technically canceling. We're not just taking out a 3. We're canceling 3 over 3. 3 over 3. So we're really canceling 9 over 9. So what's left? 2 times 2 is 4 over 5. That is what's truly happening when you simplify a fraction. You're canceling a unit multiplier, or better known as the multiplicative identity. We're going to do this again, and let's just go for a shortcut here. We don't have to get down all the way to the prime factors of 50 and 70, but we know that 50 is 5 times 10, and we know that 70 is 7 times 10, and the 10s cancel. Now, we've already learned the properties for exponents here. If there are 2 powers of x on the top and 3 on the bottom, 3 minus 2 leaves 1. So we will be left with 5y over 7x for our simplified rational expression. Finally, number 3, are we able to factor anything out of x plus 5? No. X plus 5 is a prime factor. If you can't factor, then you're prime. It's like, is there any way for us to factor the whole number 5? No, the only way to break down 5 is 1 times 5, which really isn't even breaking it down. Why? Because it's a prime number. Look at the bottom, 2x plus 15, also a prime factor. 2 and 15 have nothing in common, therefore nothing is coming out. So here's the deal, ladies and gentlemen. If nothing will factor, then you probably cannot cancel. So I know some of you are like, but oh, come on, Mrs. Hendry, can't I cancel those x's. Can't I cancel the 5 and the 15? Well, let's take a closer look at this situation. What if we took x plus 5 and 2x plus 15 and let x equal 10? If we let x equal 10, we substitute it in here, we end up with 10 plus 15 over 2 times 10 plus 15, which would be 15 over 20 plus 15, which is 35. So I'm not even going to worry about reducing it. I just want you to look at it. Well, actually, we do need to reduce it. Sorry, we do need to do that. So what if we said, okay, 3 times 5 is 15, 3, and then 5 times 7 is 35. So what we've really got here is 3/7. Okay, well, if it's equal to 3/7, would I get the same thing if I canceled the x's? One there, and then canceled here and canceled there. Okay, so that would be 1 plus 1 is 2, and 1 plus, no. Are those two equal to each other? No, they're not. We cannot cancel if we cannot factor. So let's just get that crazy work right out of the shot. So there we go. This fraction is simplified. There's nothing else to do here. Maybe one thing we could do is determine what our domain is. We could do that. What would be the domain here? This is just review from the previous video. In order to find the domain of a rational expression, you set that denominator equal to 0. 2x equals 15, 2x equals negative 15, x equals negative 15 over 2. So x cannot equal negative 15 over 2. So the domain in interval notation would be all real numbers except negative 15 over 2. So that would be negative infinity to negative 15 over 2, or negative 15 over 2 to positive infinity. So that's just a little extra something for you. Let's do 2 more problems here. And yes, I'm just going to give you quick instructions to FFCC. Factor first, then go cancel crazy. Both of these will factor. In the top, x cubed plus x squared. Remember, we are always looking for a GCF first. And the GCF of number 1 is x squared. So we're going to take that out. So x cubed divided by x squared leaves x. X squared divided by x squared. Remember, x squared over itself, that's a unit multiplier, gives you the identity. It's equal to 1. X plus 1 over x plus 1. X plus 1 is primed. The bottom is not factoring at all, but it will cancel with an x plus 1. Not an x for an x and a 1 for a 1, but that quantity x plus 1 cancels with the quantity x plus 1, leaving us with a final simplified answer of just x squared. Now, a quick reminder, if we wanted to know the domain of this expression, we always start with the original problem. So x could not equal negative 1. So the domain would be all real numbers except negative 1. That's also more amazing information for you. Number 2, FFCC. Factor first, then go cancel crazy. So denominator is probably the easiest part here. The denominator is the DOTS, the difference of 2 squares. Conjugate expressions of the square roots, x minus 5, x plus 5. The numerator, very nicely, it has a 1 up front. When there's a 1 up front, just look at that last term. What are factors of positive 5 that add up to positive 6? That is 5 plus 1. X plus 1, x plus 5. Looks like we have a identity right there. X plus 5 over x plus 5 is equal to 1. So we are left with x plus 1 over x minus 5. Once again, if we're talking about the domain restricted values, we go to the original problem. If we were to set x squared minus 25 equal to 0, then x squared equals 25, square root, x equals plus or minus 5. So our domain restricted values would be plus 5 or negative 5. That is an explanation of FFCC. Factor first before going cancel crazy.